So where is this like 1 plus c equals -5 minus 8? Oh, is that you're just
I'm taking this on the left here and I'm simplifying it to this
okay.
right here, and then this part is this right here.
Okay. Okay, cool. So, and then do you just plug that in to the first one?
You're putting the x value in. Sorry, I'm not giving you more description. I guess I thought this was clear, but it's not. So I just took this x value of 5 and I put that in here,
Right.
and then you put it into the other one, and you
Oh,
set
it's
them
still
equal.
asking for the value of c. Okay.
Yes.
All right, cool. Well, that's pretty simple then.
Should I just copy in the next few questions?
Yeah,
Okay.
that'd be
All right. Okay. This is your classic kind of true false stuff here. Okay. Classify the statement as either true or false. If f is continuous at x equals 8, then f of 8 must exist. And this one is true, but there's this progression of something being there's there's this thing called differentiability, continuity, etc. And if it's continuous at x equals 8, that means it can be drawn without lifting up your pencil like that. This is continuous.
right.
So an example of something that would not be continuous is,
That there's like a hole or like a little.
yep, maybe or here's another hole and it goes that way, or
But if that was filled in, if that top one was filled in, that would be continuous, right? Or
it would exist, but it's not continuous. So here, this is the difference. Here f of 8 exists, but it's not continuous. It's backwards from from this right here.
Okay.
So we're assuming this is true.
Okay, cool. And
so
just by looking at it, how would I know that it's true? Is that because it's like part of the
there's this if P then Q thing, and you always assume this part is true. Assume first part is true.
Okay.
But if it's backwards, if f of 8 exists, is the function continuous? So you're always looking for that counterexample for it.
Right.
I'm sorry, I don't feel like that explanation is very good. It's hard when it's true, because when it's true you have to prove it, and when you prove something, it's very mathy, and that's not what you're looking for.
Long.
Like, you almost want the one that's false, so you know you find an exception to it. Use the theorem of limits of rational functions to find the following. So it's sort of always a first starting point is you just put the x value into, whatever it is, the function there.
Right.
So you just take this -1 and you put it in there. You always just try that, and like, maybe it works. If it works, you're done. If it doesn't work, you may have to do something else, but you should at least just try it first.
Okay. All right, so then we just have the -1 squared minus 1.
-1 squared minus 1.
0.
Yes. I'm not putting answers in. Do you want me to put answers in? Does it matter for you?
No, that's fine. I can.
You're sure? I don't mind. I mean, we're doing here. Okay. We're on to question 5. So this is probably the one you're going to get on your test, unless you just get a exact copy of this unless you just get a carbon copy of your practice. So when you put 14 into this function, when you put 14 in, you're going to find that you're going to get divided by 0. Because 14 squared minus 196 is 196 minus 196, which is 0. That does not mean that B is true. It doesn't mean like, oh, it must be B. It means you need to do something else. And the answer here is you need to factor. Factor the top and the bottom.
Okay.
So how's your factoring?
Not too bad.
Okay.
I feel like it's been a while since I've factored like a little thing like this, but
Is this test proctored?
it is, unfortunately.
Okay. All right. There are tons of online calculators that help you with this. Now, the thing that's going to help you here, which one of these makes the bottom 0? Is it this left one or the right one? When you put 14 in.
The left one.
Yes, and that tells you what one of the factors is going to be up top. Because
Okay.
they're gonna cancel out. That's like your trick or your tip from the pros here to get you through that. So you have to figure out what goes here in this other place, and you're trying to go back to 3x minus 238. There's a couple of ways you can do it. You can figure out what 238 divided by 14 is, or you could figure out what's 3 away from 14, so it ends up being x plus 17.
Okay. And then what do you just cancel out the?
Those cancel, and then you were supposed to rewrite it. Like if you had to show some work, you'd have to rewrite it here. And then you try, it's like you go back and you try it again. Put 14 in, you get 14 plus 17 over 14 plus 14, 31 over 28.
Okay. Let me get this down really quick.
I will send you the notes as a PDF after we're done as well.
Perfect.
But of course, it's always good to have them.
Okay. Well, then I'll probably just go along with you, and then I'll just copy those down later. All right. Well, that looks good then.
Yep. Copying the next one in. Okay. Determine whether the function is continuous over the interval minus 6 to 6. So this parenthesis means that it doesn't include it, same thing there, but you're going from minus 6 to 6. So that's right here to here.
Okay.
So if it's continuous, that means simply you can draw without lifting up your pencil.
Okay. So it would not be continuous.
That's correct.
Even if that little hole was filled in?
Even if that hole is filled in, you still have to make it what's called a jump.
Oh, okay.
This is a jump discontinuity, and it cannot be filled in.
Okay.
Lovely. This next one has multiple parts, so we'll do the best we can here. Okay. All right, use the graph to find the following limits. You're definitely going to get a question like this on your exam.
Right.
For sure. So at 3, this right here means 3 from the left. So here's 3, but I got to approach it from the left.
Right.
And I'm looking at the y value there, so that's 3. 3 from the right. It does not have to exist. See how at 3 it doesn't exist there?
Yeah.
At that place, you're just seeing like, what does it approach?
Okay.
It approaches, what's the y value? There's 0.
0.
Okay. Now there's 2 more that it asks here. So I'm gonna just write them here so that it can get to view. C says the limit as x approaches 3. These need to be the same for that to be true. It does not exist. D is asking for the functional output at 3. Now, which is different than C. It's just asking like, where is it filled in? It's right there. It's 3.
Okay. Oh, okay. Well, all right. My numbers are different, but it's pretty much the same thing. So I just won't fill them in right now. But yeah, that makes sense.
Okay, great. Ooh, man, so your format here is tough because they give you, it looks like they're giving you a few like almost like true false, and boy, I definitely want to be certain of my answer before I answer one of these. So this right here, you're going to factor, and I'm telling you that, so hopefully you know to do that. It becomes x minus 8, x plus 8. It's difference of squares.
Right.
X minus 8 on the bottom. So those cancel.
Right.
That means you're left with x plus 8. And then this 16 here. And it's kind of the same thing that we did on that second question. You put the x value in. Are these the same? Yeah.
Okay.
So yes.
Yes, that is continuous. Cool.
Ugh, this one's horrible. You're going to be allowed to use a calculator on this test. I'm sure of. Do they let you use a full graphing calculator or?
Yeah, definitely.
Okay. Okay. All right. All right. You got to get these numbers in this table. When it says this, it means, and it doesn't tell you to round, it means that it works out exactly or nicely. So just keep that in mind.
Okay.
F of x is right here. You also need to find f of x plus h, which is minus 5 parentheses x plus h squared, like that.
Right. Okay.
So this part over here, there's 3 pieces to it. There's the f of x plus h, the f of x, and then the h.
Right.
Oh shoot! It actually wants you to do all that up here. I didn't even see that. Okay. All right. You gotta actually do this. So f of x plus h, you're gonna have to expand this thing. So I'll do that over here.
Yeah. And
Minus. Yep. And this is how I would ask you to look at it, because that way you end up not missing terms. Okay, so this simplifies to x squared plus 2xh plus h squared, and then you distribute that -5, and so it's -5x squared minus 10xh minus 5h squared. And that is, and then now you're going to subtract f of x.
Yeah.
Yeah, so I'm going to do it down here, minus 5x squared minus 10xh minus 5h squared plus 5x squared all over h. If you've done this correctly, your x terms cancel. I'm going to do that in red here.
And then
these cancel.
Factor out another h.
Yeah, then the h actually divides out, so it ends up becoming just minus 10x minus 5h. So this is minus 10x minus 5h. And then it is much easier. I led you down the wrong direction because I didn't realize it wanted a. You just fill in this table for those x and h values.
Cool.
So use your calculator, take your time. I mean, this one's 15 points. Like this is, you want this question because it's not too difficult to get all the points after you've seen how to do one like it.
Yeah.
All right, I'm snipping in the next question. This one has multiple parts as well, so I'll copy it in a couple of times here. The question says, graph this function. So you said you're gonna have a graphing calculator.
Yeah, I can just plug that in.
So that opens up. So it's either A or B, and I actually don't know which one it is, but you can figure that. You can figure that out. The the thing that, so part B here is really dependent on which graph you choose for part A.
Right, and that would be A.
Okay. I'm going to take your word for it because I don't know until I graph it, but that sounds fine. The C is like the frustrating one because unless you've taken calculus before, you have to use this right here that I'm about to circle. This is the definition of the derivative.
Right.
And this is the really long process. Do you have to show work on this thing?
I think they asked to like turn in our like scratch paper, but I don't think that they will take points off if
Okay.
we don't
No,
have.
because the derivative rules allow you to do C very quickly. And I don't know if you remember them or if we need to do it this way. You tell me what you want to do here.
Um, well, yeah, would this just be like similar to the last one? It would just be like the 2x plus h squared minus 7x plus h plus 5, and then minus the 2x squared minus 7x plus
It
5.
it is, and it's just a lot of like steps to get all the way down to the end because what happens is that you end up getting, I'm going to scroll up here, you end up getting something like at the top here, which is minus 10x minus 5h.
But then do you plug the 0 in for the h?
Right. So then it becomes something very nice. It ends up becoming 4x minus 7.
Right.
And then the last part, D here, it asks you, it says, okay, now that you've found the derivative, I want you to put the value of the derivative at 2. And that means you're going to put 2 back into this thing right here. 4
Right.
times 2 minus 7, 8 minus 7 equals 1.
Wait, so how did you get? Oh, okay. I'm looking at. Okay, that makes sense.
So I'm skipping the step of how to actually go through the limiting process. This is also, if you're looking for a shortcut, it's also the slope of that line. So whatever line you choose in part B, it's the slope of that line.
And how do I find the line from part B?
Well, it's going to match the graph. There's not. It's whatever graph you chose in A, you look for the same graph in B, part B.
But like a tangent line, like is that a horizontal?
No, it's a little bit more sophisticated than that. Like you have to find the equation of the line like you did in college algebra, which is a totally different process.
Okay.
I'm suggesting that you remember that whatever graph it is in A, part A, it's the same graph in part B.
Oh, okay. It's asking for another graph. Okay.
Yes.
I
I'm
didn't
sorry.
know if it was asking for
Yeah,
for the line.
it's the exact same graph, but like it's got a line going. One's got a line going that way, but it's there's four graphs like these above, so it's critical that you get part A correct,
Yeah.
and then the shortcut I'm telling you to part D is whatever the slope of that red line is, which I guess you're not seeing in the problem, but whatever the
Yeah,
slope of the
I
red
only
line
see
is,
like up to B.
yeah.
But yeah, whatever that slope is going to be the derivative.
Yes.
Cool.
All right, I am snipping in the next question. Okay, list points on the graph at which the function is not differentiable. So there's a couple things that make it not differentiable. The first, if it's not continuous.
Right.
So is there anywhere on this graph where it's not continuous?
Yeah, it looks like x1, x2, x4, and x1, x2, x4.
Yep. Now, the second thing you're looking for is where it's not differentiable, which is more sophisticated. But there are two things you're looking for. One is something like that, and the other is a corner. So I think this is called a cusp, and then a corner is something like that.
Right. Okay.
So at like x3, it's also problematic.
Okay.
So at x0, it's continuous, and same thing at x5, it's also continuous.
Right.
So that's why it's okay.
All right, cool.
Some of these are pretty straightforward to explain, where I almost don't even have to like, you almost don't even need to know any calculus. You just need to
Yeah,
to
kind of a
follow.
visual kind of.
Yeah, visual thing, exactly. So, all right, pasting in the next question. All right, draw a graph that is continuous but not differentiable at x equals 4. So is this one continuous?
Yes.
There's a hole though.
So,
No.
okay.
Is this one continuous?
No.
No, this one has a jump.
Right.
Is this one continuous on the right here?
Yes.
Yes, this one's continuous. Same thing with this one. So the things that are not differentiable, again, that the list is,
That little corner.
this is a corner, so this is your correct answer. So we're looking for things that are not continuous and then not differentiable, which is usually a corner or a cusp.
Okay, cool.
Did you learn any derivative rules in this class yet?
Um,
Shortcuts?
Not really shortcuts. I mean, this guy reads straight out of the textbook. He doesn't really teach anything. Like, he literally just stares at the textbook and word for word says what's on there, and it doesn't really teach you like many shortcuts to things.
You plan to have your phone out during this? Because there's like, apps on your phone, like if you go to Wolfram Alpha.
Yeah, I have those apps.
Because like this one, I mean, to do this one the way you're supposed to do, it's the limit as h goes to 0, f of x plus h minus f of x all over h. If you know the derivative rules, you know that it's just 1. So
would that be because, yeah, because you can't take like a derivative from 2 because it doesn't have a,
it's a constant.
yeah,
So the derivative of constant is 0.
yeah. Like if that was like an x squared, it would be like 2x, right?
Yes, yes. And this one does not say, this one's not like, you have everything that I see. It doesn't say like use the definition of the derivative. It says to find the derivative, which means that you can use anything you want. And that's why I'm saying, like, I would use the derivative rules. I might have an app open on my phone that to confirm what I already thought was right, so that I could
Yeah,
get.
those apps are really good for those questions. It's just they watch they watch me while I take it. So
Yeah, well, you just have to be creative about that.
yeah,
So
I'm,
this
I'm
is
in the process of discovering some new ways.
this one is what you just mentioned to me. This is a constant right here.
So it'd just be 0.
It would be 0.
And that's just another like dy over dx is just another way of saying find the derivative, right?
Yes.
Cool.
It's a point that the instructor should have emphasized over and over again. Like, this means find the derivative. This means find the derivative.
Yeah.
Okay, this is a power rule.
Right. So it would just be the 6x squared.
Very good. All right, gonna snip this in. Okay, how about this one?
Okay. So this would be negative 6x to the negative 7th.
Negative, so yeah, so it's negative 6x, and then you always subtract 1, so if it goes like that. So
Yeah.
that's it. Sometimes Pearson's really picky with how they want it entered. This would be, the one on the right will for sure be correct. This, I assume, the one on the left is probably correct, but
Yeah, I've just done the one on the left, and it's
okay.
hasn't been a problem.
All right. I mean, we're not all the way through. We're 2/3 of the way through. You're looking good right now.
Yeah, I'm good. I'm good with these things, but then it just kind of ramps up.
Yeah.
Like this, for example, is challenging.
So this one, if you rewrite it this way, it'll help a lot better. So you write it as 1/4 x to the 7/8. Okay. When you take the derivative, this constant, because it's multiplying, it just comes down. So what's the derivative of the thing I've put in parentheses?
7/8 x to the, I don't know, the 6/7 or
You're,
1/8.
you're, you're subtracting one. Let your calculator help here if you
Yeah,
can.
I'm terrible at like
Okay.
fractions.
Now it won't accept this, but if you do a little multiplying, you get 7/32 x to the -1/8.
Okay, so here I'm gonna just try to go through some of my calculators so I can get familiar with um, doing it. Okay. Mm, times x to the, and if I just plug this like top one in to a calculator, it wouldn't get me to 732x. It wouldn't
Yeah,
get this, would it?
yeah, it would. It might write it this way.
Yeah, because I
The
just
eighth root of x, it might have that, which is correct, and it'll take it.
right. I just put in 1/4 like times x to the 7/8 in parentheses, but it gave me like a decimal. Um,
Yeah, well, that's what this is. So you could always put this part into the calculator that I just circled and know that you have to multiply it by a fourth, but you might also get a decimal with that. You might get 0.875 x to the -0.125.
right. So with the decimal that it gives me when I multiply the 1/4 times x to the 7/8, that would that just be the same decimal as the 7 divided by 32?
Yes, but the
And then I
doesn't.
just have to remember to include like that x to the -1/8.
Yeah, but it will not like the decimal. Like you will not get any credit
No,
for it.
right, right. Okay. And you said you can send me this recording?
Yeah, the standard definition will be ready in the morning, but the high definition won't be
Okay.
for a while. I mean, not that you care, but it's
Uh,
it's there is some quality differences. I'll send you the notes. Um, I mean, if you need another session in the morning, we can arrange it. You just let me know.
all right.
Um, okay. Do you want to look ahead to see which? Let me either share that screen with you, or if you need to look on your own here, because I can foresee us not getting through everything, and I want to make sure we get through what
Right.
you want. So either
Right.
I'll share my screen or you look ahead and tell me what you want to do.
Here, yeah, I'll check some out right now. What are we on? 12 or
I'm up to 18.
oh shit. Okay. 18. Yeah, so 18 I would like to do just because I mean for my homeworks I've pretty much just been using that app for these.
Hmm.
And I don't really know how to like approach it.
Yep. I'll snip that in.
All right, and then I'll just keep looking. 19. Here, I'll just write them down in case you just want to do that. And then 19, I would like to touch on. Um, 20. 21. So 21 I should be fine on. I think I can just figure that one out. 22 I would like to check out. I think I'm good for 23. 24 I'd like to do. 26 and 27.
Okay, I'll do as many as I can here. So 18, find an equation for the line that is tangent to the curve y equals x cubed minus 9x at the point 3 comma 0. So the first thing you have to do is find the derivative, y prime or dy dx, which is 3x squared minus 9. Is that okay?
Yep.
All right. Then you have to evaluate the derivative at 3 because that's the x value. So that's 3 times 3 squared minus 9.
And the derivative is always the x value, right?
You're putting this x equals 3 into the derivative.
Okay.
Okay. So that's
Right.
3 times 9 minus 9, which is 27 minus 9, which is 18. So then we have to write the equation of the line. The point slope form is the one you want. And that is y minus y1 equals the slope x minus x1. Your x1 and y1 come from up here.
Yeah, so your y is just a 0.
Yep. It's not always 0, but they just happen to be on this one.
Yeah.
Normally, you would just add that value to the other side. So it'd be 18 parentheses x minus 3 plus 0, but this is what it's looking for.
Yeah. So that would just, okay. So that's just the equation right there.
Yeah, and it only wants this part on the right, you know, there. So you said 19 to go through?
Yes.
Okay. 19 is using the product rule. Is that something you guys covered?
Yeah, but
Okay.
yeah, I want to just touch on it again.
Of course. Yeah, I only ask because it's kind of a leap from what we were just doing. It's not like, oh. So there's rules for why is this thing? Sorry. There's UV. Did you see that in your notes? Like this is U
yeah.
and this is V, or F times G maybe?
Yeah, F times G.
Okay. So this is F, this is G. You have to take them individually. So F is 7x to the 4th minus x plus 6. What is F prime?
That would be 28x to the 3rd minus 1.
Yes. And then G is minus x to the 5th plus 8. So G prime is minus 5x to the 4th. So the formula for the derivative of this, and I like it in words, it's the first times the derivative of the second plus the second times the derivative of the first.
Okay.
And then you just have to match those things. So the F here is 7x to the 4th minus x plus 6 times the derivative of the second, which is minus 5x to the 4th, plus minus x plus 8 times the derivative, 28x cubed minus 1.
Okay. And when there's like a problem and it's like F like with like a little O G, is that kind of what this is?
That's composition. It's something that's kind of different.
Okay.
So this whole thing that looks horrible, this is what you put into the answer. You don't have to multiply it. You don't have to do anything except put this in.
Okay, so that's the answer.
That's the answer. All right, so you did say to skip.
I said.
To scroll up here to 22 is the next one I have on my list, but I might have lost track. 20 looks pretty.
Yeah, 20 is. Are you just kind of like 18x? over.
This one requires you to use the quotient rule. You just learned the product rule, or we just talked about the product rule. This one uses the quotient rule. And the quotient rule is a different rule. So quotient rule says if you have f divided by g, the derivative is, and again, I prefer it in words, it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So what is good to do is to take these individually and find the derivative. 18x. G is 4x cubed plus 1. What's the derivative of g?
Derivative of g would be 12x squared.
12x squared. So now it's a matter of, do you get a reference sheet or cheat sheet on this thing?
Yeah, it's open note.
Okay, so if you got this down, like all you have to do in your answer here is you just have to put these different pieces in. 4x cubed plus 1, that's g. F prime is 18x. I'm just putting in parentheses to keep it kind of contained. F is 9x squared minus 8, and then g prime is 12x squared, all over 4x cubed plus 1 squared. That's your answer.
Okay. Now,
21 is a chain rule question.
right, okay. The chain rules.
Chain rule.
Issues with.
And if it looks like you're going to get one of each. One quotient rule, one product rule, one chain rule.
Right.
So the chain rule says, this, I'm sorry, let me write it out. The chain rule. The chain rule says that you take the derivative of the outside and then you go to the inside. So like, for example, let's call this f cubed, and f is really the 3x plus 10.
Right.
The chain rule says it's 3f squared times the derivative of f.
Okay.
So the derivative of f is, over here on the right, what's the derivative of f?
The derivative of f would just be 3.
3. So we just start filling it. F is 3x plus 10 squared, and f prime is 3. You could multiply this 3 and this 3. It's up to you.
Okay. And so this 3 times 3x plus 10 squared times 3, that can be a suitable answer, or
Yeah. I mean, if you want, you can write 9 parentheses 3x plus 10 squared. You'll probably feel more comfortable doing that, but the other one is it's correct. I mean, the one on the left's correct, but it's up to you. They both work.
And that's final form. I don't need to go through.
Yep, that's it. 22. You said 22, so we'll do that one. All right. Okay, differentiate the function here. So this one has to be rewritten. It has to be rewritten as x squared plus 3 to the 1/2 power. And then it's just like the previous problem. This is really f to the 1/2 power, where f is the x squared plus 3. F is that part inside the parentheses.
Okay.
So the derivative of this is 1/2 f to the minus 1/2 power times the derivative of f.
Times the derivative of f. Okay. So, so we just do 1/2 x squared plus 3 to the negative 1/2 times 2x.
Yes, that's what I heard, and that is correct. Yep.
Cool. And I don't need to multiply that 2x by the 1/2.
You can if you want. So but here's the thing. If you're going to go that far, you can also change this minus 1/2 to be the square root of x squared plus 3 on the bottom. So I call this like the pretty solution, but it really doesn't matter.
Okay. Cool.
So this is going to have to be the end of the lesson here.
Okay.
I think I don't know that you need another lesson tomorrow, but if you do, I don't have anything on my booking form for the morning, so just text me and I'll have to add it for
Okay.
you. But what I will for sure do is send this out as a PDF right now,
Okay.
and make sure that you've got it, and then the recording just takes another little